I've got a question for you. Have you ever been on a train? I want you to imagine that you're boarding one. You find a seat, you start taking a little nap, and then at some point, you look out the window and see another train on the track next to you, just zipping past. It's going like 70, maybe 80 miles an hour. You think, wow, that train is moving really fast. But then you realize, wait a second. Maybe that train is standing still, and your train is the one that's moving. Whoa. Now, it seems like it should be easy to know when one thing is moving and the other thing is standing still. But as this train example shows, there are times when it's not easy. Like, here's another example, something that happens every day. Every morning, the sun rises in the east and follows this great arc across the sky. Then, in the evening, it goes down or sets in the west. Now, is the sun actually moving as it does this? Or are you moving and the sun is standing still? You might think you already know the answer to this question. You've probably read in a textbook or heard your teacher say, the Earth spins or rotates around its axis once each day, making the sun appear to move across the sky. But just because you heard this, do you really know this to be true? Forget what someone else told you. The real question in science is always, how do you know? How could you figure out for yourself which one is moving, the sun or the Earth? And you definitely shouldn't assume something is true just because lots of people say it's true. For example, people didn't always think the Earth was moving. In ancient times, a couple thousand years ago, when people saw the sun moving across the sky, everyone would have told you it was because the sun is actually moving. The ancient Greeks assumed that the sun was going in a circle around the Earth once each day, like you see in this diagram. We'll call this the sun moving idea. People accepted this idea for thousands of years. But then in the 1400s and 1500s, along came two of the very first scientists, Copernicus and Galileo. They said that they'd figured out some reasons for thinking that the Earth is what's moving, not the sun. They're the ones who came up with this idea that the Earth spins once each day around an imaginary pole, the Earth's axis, and that the sun stays completely still. So let's call this the Earth spinning idea, or if you want a fancy Latin word for it, the Earth's rotation. Now, many people disagreed with Copernicus and Galileo. After all, it doesn't feel like the Earth is moving. It started a big debate. But before we go any further, stop and ask yourself, is it really possible that these two totally different ideas could both explain why the sun rises and sets each day? Is there a way you could test out the two ideas right now inside your classroom? What could you do? In today's activity, you're going to make one of these, a sky viewer, and use it to explore these two different ideas to see how they can explain what we see in our sky each day. Now, to do this, you're going to have to build a model. A model is something that scientists build when they want to test out a simpler version of the real thing. So for example, a globe is a model of the Earth. Models are useful when you want to understand something really big, but you need something that's just your size. Now, instead of using a globe as the Earth, your head is nice and round, and you have a good view from there. So today, you're going to pretend that your head is the Earth. That means the top of your head is the North Pole, and the bottom of your chin is the South Pole, right? And you need some landmarks, so now imagine there's a city in the middle of the Earth, right on the tip of your nose. Let's call the city Nosopolis. You're going to look for the path of the sun as it passes over Nosopolis. To help you with this, that's where you'll use the sky viewer. When you look into the sky viewer, your eyes are looking out from the Earth, and this is what you see. The curved line there is the curve of the Earth, which has some landmarks on it. You've got the ocean, you've got the city of Nosopolis there in the middle, some mountains, and a few other things. Now, using the sky viewer, you're going to compare what sunrise and sunset look like in two different situations. First, you'll watch as the sun travels around you, like the ancient Greeks thought. And then you'll watch the sun as the Earth spins in place. In other words, as you turn your body and the sun stands still. Are you ready to start the activity? Here's what you do step by step. Get your starting supplies. You'll get more supplies later. When you're done with this step, click the arrow on the right. Take a minute to color in the landmarks. Cut out the eye hole. To make the first cut, pinch the paper like this. Then, to finish cutting, unfold it. Here's a tip. You can turn the paper instead of turning the scissors to make cutting easier, like this. Cut on the 5 dotted lines. Be sure to stop cutting at any stop signs you see, like these. Using your ruler, fold all the solid lines up like this. Use the paper clips to fasten the corners, like this. Find a partner to work with. This should only take about 10 seconds. Go! Both of you look through your sky viewers. Notice which side is east and which is west. Whenever you use the sky viewer, you should keep your nose pointed right at Nosopolis, the city at the center. You can move your eyes to look around, but don't move your head. Decide who will be the Earth and who will be the Sun first. Then get a paper sun from your teacher. Each group find a space on the floor large enough to hold out your arms. Teachers, you might have to move desks out of the way so everyone has room. Earth, stand still and look through your sky viewer. Sun, move so Earth can see the paper sun in the east over the ocean. When the sun is in the east, it's sunrise. Work together to act out the sun moving idea. How should the sun move so it rises in the east and sets in the west? Use the paper sun and sky viewer as you do this. Once you get the hang of it, keep going until Earth has seen at least 3 sunrises and sunsets. Now work together to act out the Earth spinning idea. How should Earth move to make the sun rise in the east and set in the west? Once you get the hang of this, keep going until Earth has seen at least 3 sunrises and sunsets. Switch jobs and act out both ideas again so everyone has a chance to use a sky viewer. Discuss these questions as a class. Afterwards, click the arrow on the right to watch the next video. Let me show you what we saw when we used our sky viewers. When we assumed the sun goes in a circle around the Earth, it looked like this. So this could definitely explain why it looks like the sun is moving across the sky each day. See? And when we assumed that the Earth is spinning while the sun is still, it looked like this. This also makes it appear the sun moves across the sky each day. So as you can see, both ideas definitely would explain why the sun appears to move across the sky. So how do we know which is true? How do we figure this out? It was those two very early scientists, Copernicus and Galileo, who were the ones to discover that the Earth is spinning. The sun doesn't move around the Earth. The sun stands still. Now, almost no one agreed with them at the time, only a handful of people. And you can kind of understand, right? I mean, to those people, it seemed crazy to look at this and say that the sun isn't moving. People would say to Copernicus and Galileo, "Look at it. It looks like the sun is moving. And besides, if the Earth were moving, wouldn't we notice that here on the ground?" But remember that train example. It's not always easy to tell when something's moving, even when you're on it. Copernicus and Galileo had collected a lot of evidence and they'd done a lot of thinking to figure out that the Earth moves. Now, the details, if you're curious, involve a part of science called physics and also some high school level math called trigonometry. But now, since you're living in the 21st century, there's a much easier way to prove that the Earth is what's moving and not the sun. And that's to get off the Earth, go into space. If we were to get far enough away from the Earth, we should be able to actually see the Earth spinning or rotating. Now, here's a spacecraft that traveled far enough away from the Earth to film it spinning. It was launched into space in 1995, and NASA named it Galileo. There wasn't anyone on board, so NASA was controlling it using a remote control on Earth. A few hours after they launched it, they turned its camera to point back toward Earth, and it took this video, which we've shown sped up. You see the continents moving there? Here are some other images taken by a NASA spacecraft. This is a different one, about 1 million miles away from the Earth. Not only can you see the Earth spinning, you happen to notice the moon moving by as well. So here you have it. This is video proof that the Earth spins. By going into space and looking back at Earth, we can see direct evidence that the Earth is moving and not the sun. Galileo and Copernicus would be proud. Now, I want to leave you with one final video. Even though today we can send rockets into space and see the Earth is spinning, you and me, we live down on the Earth's surface. So it can still be a little hard to accept that the sun rises and sets because the Earth is moving. I mean, look at this. It really looks like the sun is what's moving. So here at Mystery Science, we decided to film one final experiment to show you. Here's what we did. We used a globe for the Earth, a lamp for the sun, and then stuck a tiny person on the globe. I call him Lego Man Joe. Okay, so let's move the camera behind Joe so we can see what he sees. Now, in a second, I'm going to start spinning the globe like this, just like the real Earth spins. But I'm not going to touch the sun. I'm going to make it stay still. Okay, so let's watch what Lego Man Joe sees. We start out, he's in nighttime, and I start spinning the globe, and there's sunrise. See? So the sun's going up. Now it's getting to be late morning. Okay, the sun's at its highest point. I'm going to turn Joe around here. It's noon, and I'm turning him so he can continue to watch the sun. Now I'll keep spinning the globe. You see what the sun is doing? Or what it looks like it's doing? It's getting lower. And okay, sunset. So it really works. I hope this helps you. Next time you watch a sunrise or sunset, now you can picture the real reason. It's the Earth spinning. See you next time.